Okay, so now we're doing 3.1, graphing quadratic functions. So what are quadratic functions? So first we're just going to look at lots of different functions. Okay, so if I have a function that doesn't have any x's, or has an x with a power of 0, which really means there is no x's, it's a constant function and it's a horizontal line. Okay, we're not going to talk about those. If I have a function that just has an x to the power of 1, then this is a line, a straight line, and we call it a linear function. Okay, and we have this thing called degree, and degree just means what's the biggest exponent on the variable. So here's the variable x, the biggest exponent is 1, because there's only one variable, so the degree is 1. But now I have two x's, I have 1 and a 2, and I say what's the biggest exponent? Well, 2 is the biggest exponent, so the degree of this function is 2. Okay, and this is the functions we're going to talk about in this book. So when we have a degree of 2, or a function that has an x squared, then where the degree is 2, where the biggest exponent on an x is x squared, then we call it a quadratic function. So when it's a function written this way with x squareds and numbers and x's, we call it a quadratic function. When we draw it and you actually can visually see it, then the shape is called a parabola. So this is called the parabola and this is called the quadratic function. Now some people say that this is a parabola. It kind of is, because if I graph it, it becomes this. But that's just to help you understand the difference. This is the parabola because it's a shape, and this is the quadratic function because it's like a sentence of numbers and letters. Okay, so when I look at it this way, if I have a degree of 3, which means the biggest exponent on the variable is a 3, then it's a degree of 3, and we call it a cubic function. If the biggest exponent, because here I have a 4, a 3, and a 2, but my biggest exponent is 4, the degree of the function is 4, and we call it a quartic function, and that's what it looks like. So this book is about quadratic functions, when the biggest exponent on the x is a 2. Okay? So let's just look at a little bit of vocabulary. Okay? So a quadratic function is when it looks like this, and a, b, c are real numbers, so you have a number here and a number here and a number here, but the number in front of the x squared can't be 0, which means it can't make this term disappear. You have to have an x squared for it to be called a quadratic function. We can write it this way in standard form, or we can write it this way in vertex form. And we call this form vertex form because whatever numbers are here and here give us the vertex. And you say, what's the vertex? The vertex is the point at the very bottom of the parabola or at the very top of the parabola. So whatever point this is, it's here. Okay? And then also we go, this h here tells us the axis of symmetry. So whatever number this is the line that cuts these parabolas in half. And I'll show you what that really means. Okay? So let's look at some vocabulary. So here's a parabola that opens down, and here's the vertex. It's at the very top. And then here's the axis of symmetry. And the axis of symmetry is just a line that cuts my parabola exactly in half, and it's the same on both sides. So here's a parabola that opens up. Here is my vertex at the bottom. And the axis of symmetry is this yellow line here. It just cuts it both in half. So if I look at this, here's a parabola opening down, and my axis of symmetry is at x equals 2. What's this point here? This is the vertex, and my vertex is at point 2, 1. And here is a parabola that opens up. My axis of symmetry is x equals 3. And here is my vertex, and my vertex is at 0.3, negative 4. So you can see that the axis of symmetry is always going through the vertex. It always goes right through the vertex. Okay? Let's look at the next page. Now this is review of, I think it's 2.7. We talked about this already. So if I have here a negative number, negative x squared, so say there's a negative in front here, it means the parabola opens down. If it's positive, it means the parabola opens up. Okay? So if it's a half in front, it squishes it. So if you think of like a teddy bear and I squish it by half, it gets wider. And if I have a teddy bear and I pull it and I stretch it by 2, double the size, it's going to get skinnier. Here's my parent parabola, my normal one. But if I add these two numbers inside the brackets, you have to remember inside it's going to be opposite. So if I have a negative 2 on the inside of the bracket, it means right 2. And if I have a positive, it's going to move it left 2. But here, if I have a positive number here on the outside, it's going to move it up 2. And if I have a negative number here, it's going to move it down 2. So let's just do a little review of that. So it says match the quadratic functions with its graph. Okay, so if I look at this one, the first thing I can see is a negative, and then I can see this 2. Well, the negative means it's going to open down, so it can be this one or this one. And then this 2 on the inside means it's going to move left 2. So it's opening down and it moved left 2. So this function is this one here, because you can see it moved 1, 2 to the left. So here there's a half in front. So I think of a teddy bear. I'm going to squish it, make it go half. And when I squish the teddy bear, it gets kind of wider. So these two down here are a little bit wider. But then this 2 says, please move it left 2. So which one's moved left 2? This one has moved left 2. So this one is here. Now I have a negative. So this one is upside down because that makes it go upside down. This 2 says, please go up 2. So it's upside down and up 2. So this one is the green one. Half means like if you take a teddy bear and you squish it, it gets wider. Okay, so you can see this one's wider than this one because it's been squished. And this 2 says, please go up 2. So you can see he's gone up 2, and he's a little bit wider. So this one is this. Okay.